Okay, question 10. We have to look at the graph, for part 1 at least, we need to look at the graph x squared over a squared minus y squared over 2a squared is equal to 1. We recognize this fairly comfortably as being a hyperbola with a horizontal orientation, and we can tell that its center is going to be 0, 0. So let's just draw on a few details first. Again, you know that I'm a little bit handicapped here. That's worse than even I'm willing to accept, though. So if you would be kind enough... no, okay, don't do that. Something bad going to happen. I feel something bad might happen. No, nothing bad happened. Okay. Yes? No? Okay. Right. Here we go. So center 0, 0. Now because I've got an a squared down here, I know that my horizontal distance from the center will be a units. So this point here is a, this point here is minus a. And I suppose given how they've asked the question, I should phrase that as coordinates as well. I might do that a little bit later. We shall see. But in the meantime, we'll just leave those there. And what about the asymptotes? Well, in this case, for asymptotes, we solve the equation. As x and y become very large, the 1 becomes less relevant. So we solve the equation x squared over a squared is equal to y squared over 2a squared, which simplifies quite nicely to y is equal to plus or minus root 2 times x. So 2 lines passing through the origin. So this is y equals to root 2x. And another line like that, which is y equals to negative root 2x. And so we can draw in our hyperbola as such. Yikes, okay, that was a bit wonky. Let's see if I can undo that and try again. Yep, okay, that's a little bit better. And that's alright. Okay, so this is our line x squared over a squared minus y squared over 2a squared is equal to 1. And this is the coordinate a0, and that's the coordinate minus a0. Part 2, by sketching a suitable curve on the same diagram, find the solutions to the equation x squared over a squared minus a squared minus x squared over 2a squared equals to 1. So this is obviously what's happened is we've replaced y squared with a squared minus x squared. Or in other words, we want x squared plus y squared to equal to a squared. This is a circle centered on the origin, radius a. So the second suitable curve I'm going to draw is I'm going to draw it in like this. So this is the point 0a up here. Definitely, oh yikes, that's not so nice. It's definitely going to pass through this point, a0. Going to go down and hit 0 minus a as well. Sorry, so again, not very neat. I expect you guys can do a fair bit better than I can. Can I delete that? Okay, so this is circle centered on 0, 0. Circle, center, 0, 0. Radius is a. Alright, so that's part 2. find the range of, part 3 is find the range of values of b for which the graph, this has 2 points of intersection with c. So the graph that I have here is the graph of x minus b squared plus y squared equals to b squared. So this is a circle centered on B0, radius b. So again, let's just try some things out here. If my point B were here, right, at A, then the circle would look something like this. Right, the center would be there, and it would go all around, and definitely would have 2 points of intersections. However, if I chose a much smaller value of b, I hope I can undo all that, slowly disappear. So maybe I took my b to be in there somewhere, then, well, the radius would be b, so it would only look like that, and there would be no point of intersection, right? Now, there's a particular value where if I choose it to be exactly halfway between 0 and a, that is, if I choose the value a over 2, then the radius of b means that it will just touch the curve at this one point here. So that's if I take the point a over 2 as my center. Now, in this case, there's 1 point of intersection, but so long as b is just a little bit bigger than a over 2, then that is sufficient. However, that's not the only way I could work. I could also take b to be a negative number, right? So I could take b to be negative a over 2, and I would get the same situation appearing on this side, right? So the answer is I can take my values of b, so to have 2 points of intersection, with c, I would need to have b to be larger than a over 2 or b to be smaller than negative a over 2. That's exactly the same thing as saying that b has to be larger than that's the same thing as saying mod b must be larger than a over 2. Okay, cool. So the last part is where it gets quite tricky. The graph of this has 2 points of intersection for any constant b. Find c in terms of a and b. So if we imagine what this would look like, so this is 10 part 4 now. Yep. Let's just imagine what that looks like. I still have my curve C. I'm going to ignore what I found in parts 2 and 3 here. Y equals to square root 2x. Oops, okay, that didn't go so well. Negative square root 2x. Right. And I have my hyperbola. As such, okay. Now, what does this graph, x squared plus y minus b squared equal to c squared, look like, such that it has 2 points of intersection with C for any constant B. So find C in terms of A and B. That means that when I draw this graph, this is a circle, right? And its center is 0B. So up here somewhere. And it has 2 points of intersection. So this is the interesting part, right? That if I draw the circle too big, like such, then I'm going to end up with 4 points of intersection. But if I draw it too small, I'll end up with no points of intersection. So I need to draw it somewhere in between those two. It needs to be big enough so that there are some points of intersection, but not so big that there are 4 of them. And so for there to be exactly 2, you get something that looks kind of like this. Oops. Yeah. So pretend that only intersects once. Now, you find that if you do this, the y values for the points of intersection are identical. So this is an important observation. It will have the same y value, the 2 points of intersection. So, okay, how does that help us? Well, remember that this is the graph x squared over a squared minus y squared over 2a squared is equal to 1. And we've got this equation here, x squared plus y minus b squared is equal to c squared. So I'm just going to substitute this equation into this one. Now, because I've noticed I've got the same y value, I'm going to eliminate my x variable. So I actually get c squared minus y minus b squared over a squared minus y squared over 2a squared is equal to 1. And let me expand that out. That's going to be 2c squared minus 2 y squared minus 2by plus b squared minus y squared is equal to 2a squared. And so when we simplify this one, we find we get minus 3y squared plus 4by plus 2c squared minus 2a squared minus 2b squared is equal to 0. Now we know, because there is the same y coordinate for our points of intersection, that the discriminant d should be 0. There's only one y solution. Although there are 2 roots, there's only one y root. So therefore we should be able to say that 4b squared, take 4 minus 3 times 2c squared minus 2a squared minus 2b squared equals to 0. And so if we simplify that, we end up with 24 c squared minus a squared plus b squared is equal to negative 16b squared. Yep. And that gives us c squared is equal to negative 2 over 3 b squared plus a squared plus b squared. Just dividing through by the 24, then moving this part over. And that means that c is equal to the plus minus square root of a squared plus 1/3 b squared. And that is our final answer.